호랑이는 죽어서 가죽을 남기고 사람은 죽어서 똥을 남긴다? 모든 질병은 장에서부터 비롯된다. 히포크라테스가 남긴 말입니다. 이처럼 우리의 건강은 장속 안에 있는 미생물에 의해 결정된다고 볼 수 있습니다. 하지만 이 중요한 장내 미생물에게 2000년간 많은 변화가 있었는데요. 이 변화 때문에 과거에는 없었던 새로운 질병들이 현대에 유발되고 있습니다. 도대체 어떤 변화가 있었는지 네이처 연구에 실린 연구 논문 저자, 하버드 의대 교수인 프로페서 코스틱과 함께 인터뷰를 통해 자세히 알아보도록 하겠습니다. Please welcome Dr. Alexandar Kostic.
Yes, thank you so much, Jennifer, for inviting me to your show. My name is Alexandar Kostic. I'm an assistant professor of microbiology at Harvard Medical School. And I study the microbiome, which is the collection of trillions of microbes that live on all of us.
To start, I have to ask, how on earth did you decide to conduct your research on such a niche subject? It's not every day that you see a comprehensive study on 2,000-year-old poo.
And one thing that we observe in the recent decades, certainly in the United States, and I'm sure that this is probably true in Korea as well, this increasing incidence of obesity, as I mentioned, and type 2 diabetes, allergies, and also autoimmune conditions like multiple sclerosis and inflammatory bowel disease. And what is the reason that these diseases are getting worse and worse over the decades? The microbiome is changing over time. That's kind of what's been observed. And the biggest observations have been that the microbiome is much more diverse in these non-industrial people. That's why it was important to go back in history to see what was it like really a really long time ago, before we had any kind of access to a urban or industrial lifestyle. But it's really impossible to understand that completely without being able to go in a time machine, essentially. And that's why, because of all of this, that's the reason why I teamed up with archaeologists and anthropologists, and we started digging through caves to try to find the paleofeces, the poop of our ancestors, to help answer this question. Paleofeces that came from extremely dry caves, where we know the preservation is really good overall because it becomes desiccated, completely dry, very rapidly.
How easy is it to tell the difference between the animal and human feces, especially when it's thousands of years old?
That's where really the most of the work went in this study, to really authenticate them as ancient and human paleofeces. Because the alternative is they could be from dogs that often go in these caves. And so a lot of clues had to be gathered. First, by microscopic analysis of these paleofeces, even before extracting any DNA, we could see particles in the stool, and particularly food particles. And the kind of particles we saw were consistent with a human diet. They contained things like grains, corn. They contained fungi that humans were known to eat. And they even contain some parasites, which we know for sure are human parasites and not dog parasites, because there's very little overlap between the two.
Okay, that's very interesting. Would it be possible for you to explain your research process in further detail for our viewers who aren't familiar with gut microbiomes?
When we extract that piece of the sample and eventually extract the DNA, we were able to see about fragments that are about 300 base pairs long. And we were able to do that for nearly 500 bacterial genomes for all of our 8 high-quality human paleofeces. And that was the first time that from ancient microbes that we were able to reconstruct, in many cases, nearly complete bacterial genomes.
Wow, that's amazing, Professor Kostic. And then how could you compare with those ancient genomes to the present one?
Excellent question. So in order to do that, we can measure a very basic thing, which is just the overall similarity in the DNA across the entire genome of the genomes we have and all of the existing known bacterial genomes, of which there are probably nearly 1 million today that exist. And what we found was that 60% of the genomes we reconstructed were very close to known bacteria, and specifically bacteria that are known to inhabit the human gut. And even more specifically, bacteria that are more commonly found today in non-industrial communities and generally less common in industrial communities. 40% of the genomes were completely new species that we've never seen before.
Okay, and based on your findings, what do these changes in gut flora mean for people in the present day?
It fits well with this hypothesis that we have and that other people in our field have of extinctions that are happening in the human microbiome. Over time, and particularly with our changing lifestyles, microbes are going extinct. And so I think that this is really our first clue into these microbes, and we have more than 200 of them, that appear to have gone extinct.
So you're saying that only 60% are similar and 40% are totally different, right?
Exactly.
And is that the reason why these days we got the new diseases because of those difference?
Yeah, that's one leading theory is the reason for this dramatic increase in chronic diseases is because we're losing our beneficial microbes. It's very hard to establish pure causality with the microbiome, and so what we're kind of working with is correlations. As the incidence of these diseases rise, we see changes in the microbiome. For example, in obesity, there was a really excellent study that looked at twins, where one twin is obese and one twin is lean. Genetically, they're identical, but they have a different microbiome. And so now if you transfer their gut microbiome, their poop essentially, into mice, the mice that receive the microbiome from the obese twin now becomes obese. And the mouse that receives the microbiome from the lean twin stays lean. Since then, there's been many other examples where people have done similar things like that for inflammatory bowel disease, allergies, and even autoimmune diseases.
Wow, so microorganism is that very important.
Yeah.
Okay. Do you have any recommendations for people who want to change their lifestyles and dietary habits to prevent microbial diseases?
And what we're really starting to understand from the microbiome field is that your microbiome is shaped by your diet. It's also shaped by your exercise. The more you eat a healthy diet, particularly a diet high in fiber, and the more you exercise, the more you promote a microbiome that then in turn gives you an extra boost on top of all of that, not just the nutrients from the food and the exercise itself, but extra metabolites that you receive from your microbes. But in the future, not too distant future, hopefully we'll have some new microbes as probiotics to give to people as well.
For the exercise, what type of exercise do you recommend more specifically? And then how many times do we have to do?
I think the more the better. We did a study of runners in the Boston Marathon, and what we found in these elite marathon runners, something completely different from sedentary people that don't exercise at all, is these bacteria in their guts that metabolize lactate, which, as you might know, is produced by muscles during exercise. when the microbes metabolize this lactate, they produce it into secondary metabolites that give the muscles an extra boost of energy and also help to reprogram the muscles so they are able to exercise even more efficiently in the future.
Okay, as you know, patients with C. diff are treated with fecal microbiota transplantation. Then, can we restore ancient intestinal microorganisms and transplant them into the feces to either prevent or cure diseases?
You're right. I mean, Clostridium difficile is one disease right now that's being treated with FMT. Right now, there are trials that are looking good in inflammatory bowel disease, even cancer therapy, as you might be familiar. Treatment with immunological drugs, checkpoint inhibitors, sometimes work in some people, sometimes don't work. But when they're supplemented with FMT, generally the response is even higher. We can create even more impactful fecal microbiota transplants.
Hopefully we can do that in the future. In your opinion, how do you envision microbial DNA to look 2,000 years from now? Do you think there will be a significant difference, or will microbial DNA resemble that of today?
I think one important point is that communities right now across the world living a traditional lifestyle, they're losing their land, they're losing their forests. Soon enough, these people will disappear and their microbes along with them, and unfortunately, and that's very sad news. But in our ability to document and collect their microbiomes, in addition to ancient people, we'll be able to build ancestral human microbiome that I think will be used synthetically in the future.
Yeah, hopefully it will be.
Yeah.
I'd like to know if there are any interesting or funny moments you encountered during your research. Do you have any stories to share?
I don't know about funny stories, but definitely interesting things. One thing is really cultural value of these paleofeces. Something that in our culture in the West is something we disregard as kind of, it's poop. But actually in the communities that we received our ancient paleofeces from, particularly the Native Americans, they treasure this is part of their ancestor and a part of their relationship with the earth. And actually, I'm kind of beginning to agree with their opinion, because really these microbes are more than just waste. They play such an important role in our health and who we are. And so actually in these ancient paleofeces is really a big clue to who their ancestors were and how they lived their lives. I didn't think there would be such a cultural relationship, but it really turned into something, in my opinion, that was quite beautiful.
Yeah, I mean, it was very surprising. I didn't know about that cultural difference too.
Yeah.
That's very interesting. So this is my last question. Lastly, are there any final thoughts you'd like to share with us before we wrap it up for today?
The next step is now to collect paleofeces from a much larger time scale, 5,000 years ago in different continents, in South America and Africa, to build a real concise picture of what exactly are the extinct microbes.
Okay, well, thank you so much for taking the time to meet with me for this interview, Dr. Kostic. I look forward to seeing you again soon. Until then, wish you all the best. Bye-bye.
Bye.